Hello everyone, so in this video will be the continuation of our discussion on central limit theorem. This will be the part 2 of that video. So we have here the second example. Opinion Research Corporation reported that the average time of men in the shower is 11.4 minutes with standard deviation of 1.8 minutes. If the times in the shower are approximately normal, the question here is, what is the probability that the mean time for 20 randomly selected men exceed 13 minutes? From the given problem, we can deduce that the population mean is 11.4, population standard deviation is 1.8, sampling mean is 13, and sample size is 20. So we have here, or what we are asked for is the probability that the sampling mean will be greater than 13. First, let us convert 13 into its corresponding z-score. So how are we going to do that? By using the formula. So we have here z equals x bar, or the mean, sampling mean minus population mean, all over the population standard deviation divided by the square root of the sample size. Since we have this values, we're just going to plug it in and then solve for z. And if we're going to input this in our calculator, we should arrive at 2.74. Since we already have 2.74, we are going to look for it in our z table, or we are going to use the z table to find the area below 2.74, and we can find there 0.9969. Now, um, since we are asked for the probability that z is greater than 2.74, like probability that the sample mean is greater than 13, we are going to subtract the probability that z is less than 2.74 to 1. And I've already discussed this on our previous video. To be more specific, in normal distribution, and so we have 1 minus 0.9969. This is the value that we obtain from the table. So subtracting it, it gives us 0.0031. It goes to show that the probability that z is greater than 2.74 is equal to 0.0031. And since these two are equal, or these two probabilities are equal, it goes to show that the probability that 20 randomly selected man, their mean in time, or their mean time in taking a shower will exceed 13 minutes is 0.0031. For our third example, we have the mean NAT scores of grade 10 students is 65. So we already have mean as 65, or the population mean as 65. 60 students means this will be the sample size were chosen and found that the standard deviation of their scores is 5. So this will be the sample standard deviation since it is taken from the sample 60. The question here is, what is the probability that their mean is between 64 and 67? So we have here two values for x, and this will be the boundaries of the area. Now, for the so let us solve. We have here mu as 65, sample standard deviation as 5. The first one, or x sub 1, x bar sub 1 is 64, x bar sub 2 is 67, and the sample size is 60. And if we're going to put that in our formula, we have here 64 minus 65, 64 minus 65, all over 5 divided by square root of 60. 5 divided by square root of 60. So same goes with the second one. The only difference is x sub 1 and x sub 2. So from the first, we have negative 1.55, and from the second, we have 3.1. So those are the two values for z. Using the table, the probability that z is less than negative 1.55 is 0.0606, and the probability that z is less than 3.1 is 0.9990. So what we are going to do here to find the probability that z is greater than negative 1.55 but less than 3.1 is we are going to subtract the two obtained values, or the smaller obtained value to the bigger obtained value. So that will be 0.9990 minus 0.0606, and that will give us 0.9384 or 93.84%. It goes to show that the probability that the sampling mean or the sample mean falls between 64 and 67 will be 0.9384, or the probability that the sample mean is greater than 64 but less than 67 is 93.84%. For this, it is just some exercise for you if you have time, or if you exercise your skills in computing the z. Same goes with this one. Compute z and the area of probability indicated. For my reference, I used the Statistics and Probability for Senior High School, published in 2016. The author is Banigon, Camilan, and Manalo. And if you find this video helpful, you may hit the like button, click the subscribe button, and share this to your friends. Also, click the notification bell so that you will be updated if I post another video that will be helpful for your course in statistics and probability. Thank you.